My name is Duncan Keenan-Jones. I'm a researcher here at the Collegium de Lyon, and my project seeks to reconstruct the climatic variations that occurred in ancient central Italy, and then to compare those variations to the archaeological and historical record in order to see how the unusually dense urban networks in this area managed to react to changes in climate. In particular, my project focuses on Puteoli, one of Rome's major ports, and to examine the way in which this town reacted to the half a millennium, really, of volcanic events and geopolitical instability. The reason why I chose the Collegium de Lyon was, in a sense, in fact, the Collegium chose me. In 2014, I was approached by researchers from the Laboratoire Archéologique and Universités de Lyon 2, and from the Laboratoire de Géologie de Lyon and the l'UNS de Lyon, with an offer to collaborate. But during the two papers that we wrote together, I was very impressed by the innovative research being carried on at Lyon, by the expertise in geochemistry and geoarchaeology that was there, by the collaboration between the different entities that made up the Universités de Lyon, and also by the facilities, particularly the geochemical analytical equipment that was present there. I could see that an extended stay would be a great step forward for me in my career, and that was why I applied to the Collegium de Lyon. My research, or I should say our research, is unusual in that it closely integrates the analysis of Greek and Latin texts, archaeological evidence, and also really three fields of geology: geochemistry, carbonate sedimentology, and clastic sedimentology. In doing so, it answers questions which are pertinent to all these fields. The introduction of geoscientific techniques means that that historical and archaeological questions which before were difficult or even impossible to answer can now be asked. At the same time, the mineral deposits that are formed in ancient water systems are a laboratory to investigate the formation of these deposits over long periods of time and also under relatively well-defined flow conditions. My work at the Collegium forms part of a larger project to investigate the unusually dense urban networks that are formed in Roman and ancient central Italy. In particular, I would like to see how these networks responded to various outside stresses, and this will form a case study pertinent to similar urban systems present in the contemporary world. As part of this work, we are producing the first high-resolution and reliable climatic reconstruction of ancient central and southern Italy. This data will be shared with the Past Global Changes, or PAGES project, and this will remedy the current lack of such climatic data from ancient central Italy. This will allow improved testing and calibration of the models that are used to predict future climate variation. And in so doing, this will allow improved prediction of impacts and planning of mitigation efforts. At the same time, our work around the Bay of Naples investigates the two different volcanoes located in this area and the changes that occurred in them before and after eruptions and earthquakes. Since the modern city of Naples, with 3 million inhabitants, lies atop these two volcanoes, such improved data for the prediction of future events could result in significant reductions in loss of life and damage to property.